Hi guys! We're going to look at set operations. So the first thing is the length of a set, or rather the cardinality of it. So we're going to get back the number of unique elements in the set. So here, this set is actually just 2, 3, 4. So there are 3 unique elements. The cardinality is therefore 3. Next we have copy. This just produces a copy of the set. So here we have S, which is 1, 2, 3, and T is a copy of that. When we add 4 into S, it did not change T at all because they're not aliased. We have pop. Pop just removes and returns you a random element from the set, so it works a little bit differently than pop with lists. Clear removes all of the elements from a set, so you always get the empty set back, and the empty set has the cardinality of 0. Okay, now we're going to look at operations on sets and elements. So we can test for membership, and we're going to see if certain elements are in our set. So here we're checking to see if 0 and 1 are, and 1 is, 0 isn't. Just as easily, we can see if elements are not in our set. So we sort of get the opposite back here. We have a really useful method called add, and this just adds elements into our set. So here we add 4, we print it out again, now we have 1, 2, 3, 4 in our set. I want to show you really quickly that if we try to add 4 again, nothing bad happens. Rather, nothing really happens. So when you try to add an element that's already in a set, nothing happens because sets don't have duplicates. We have remove. Remove takes out a certain element from the set, so we can remove 3 from 1, 2, 3, and then we just get 1, 2. However, if we try to remove 3 again, since 3 is not in our set anymore, it will crash. To fix that, we have discard. So discard does not crash if you try to remove an element that's not there. So here, 3 was not in our set. We try to remove it again, or rather discard it, and it does not crash. Okay, moving on, we have operations on 2 sets. So we have is subset. So we have 2 ways of writing this. We can actually do the operation using the less than or equal to sign on 2 sets, or you can actually write is subset. Both do the exact same thing. So we're going to see if the set 1, 2 is a subset of 1, and we see that it's not because the set on the right-hand side is missing 2. So not all of the elements that are in the set on the left-hand side are also in the set on the right-hand side. However, we see that 1, 2 is a subset of 1, 2, and 1, 2 is in fact a subset of 1, 2, 3 because 1, 2, 3 contains 1 and 2. Is superset kind of works the same way, but a little bit opposite. So instead of checking to see if the elements on the left-hand side are in the set on the right-hand side, we're going to check and see if the elements that are in the set on the right-hand side are in the left-hand side. So 1 is in 1, 2. 1, 2 is also in 1, 2. However, now we have 1, 2, 3, and 3 is not in 1, 2. So we cannot say that 1, 2 is a superset of 1, 2, 3 because it does not contain 3. So that's why we get false on that very last call. Now we're going to check out union. So union gives you a brand new set with all of the elements that are from both sets that you're comparing. So here, we're going to take the union of 1, 2, and 1, and that's just 1, 2. However, when we take the union of 1, 2, and 1, 3, we get 1, 2, 3. And then here, once again, we have the set 1, 2 assigned to S, and then we're going to take the union and assign it to T. So this is just showing you really that whenever you do this, we get a brand new set in T, but we didn't change S at all. So S is still 1, 2, and T is now that new set that has 1, 2, and 3 in it. Okay, so intersection gives you a new set with the elements that are common to both sets that you're comparing. So here when we take the intersection of 1, 2, and 1, we just get 1 back. The same thing happens when we take the intersection of 1, 2, and 1, 3, we just get 1. And then we're doing sort of a similar thing down here, just showing you that S is not modified, and T is that new set that is the intersection of 1, 2, and 1, 3, which happens to be 1. Difference gives you a new set with the elements that are in the first set but not in the second set. So let's take a look at that. So the difference between the set 1, 2, and 1 is just 2. Here the difference is 2 again, because it's going to take out this 1 from this set because it's common to both. And then we do the same thing down here, and we see that S was not modified. We have symmetric difference, so this gives us a new set with the elements that are in either of the sets that we're comparing, but not both of them. So the symmetric difference here is just 2, because we took out 1. And here the symmetric difference is 2, 3, because once again we took out 1. And then we have update. So update modifies that first set, and it adds all of the elements that are found in the second set. So when we update S with U, so when we do this call right here, we're going to add 3 into S, and we can see that right here. And then we're going to perform the same operation, but we're going to instead add all the elements in U into T. So now we get 1, 2, 3 again, or 1, 3, 2. Order doesn't really matter for sets. But then we see that U has not changed throughout this process. So U is still 2, 3 at the very end. We have intersection update right here. So this modifies the first set, but it keeps only the elements that are also found in the second set. So if we look at S, which is 1, 2, and U, which is 2, 3, it keeps only the elements that are found in the second set, so it just keeps 2. And then if we perform the same operation on 1, 3, and 2, 3, it's just going to keep 3 this time. And then U has not been modified. Okay, we have difference update. So difference update modifies the first set, and it removes all of the elements that are found in T. So it's kind of the opposite as the other one. So here we have 1, 2, and 2, 3 once again. When we take the difference update, though, we get 1 because it removes 2 since 2 is found in U. And then we can do this a similar thing with T and U. So 3 is in U, so now T will have 3 removed from it. And then once again, U has not been changed through that process, but T and S have. And finally, we have our symmetric difference update. So this modifies the first set, and it keeps the elements from either S or T, where S is our first set, but not both of them. So here our symmetric difference between S and U is 1 and 3. And then our symmetric difference between T and U is 1 and 2. And then once again, U has not been changed by these operations. So there you have it. Those are operations on sets.